Welcome to building your initial NGSS capacity. This is the starting line. The NGSS is a marathon, and this first webinar is intended to give a basic overview of some tools and what we think of as the first steps that should be taken when you begin that NGSS marathon. We're going to talk about things today that are really theoretical, and we also have some concrete activities that you can use to try these things out in your classroom. We also have 2 more webinars that will focus around this implementation journey. So there will be kind of like a building strength, and then there's like peak performance, are these like marathon term things that we came up with to help provide some context and some framing around where you can get started, what you should focus on next, and then where we see our top performing partners working into and diving into. So let's launch ourselves into this with some introductions. So first off, hello everybody. My name is Brendan Finch. My pronouns are he, him. I taught middle and high school science for 7 years in Los Angeles. I taught for LAUSD and KIPP and Green Dot and a virtual charter school, which was interesting. I left the classroom in 2014 or 2013 to build rocketlit.com. It's an adaptive science reading program. And then over the last, it's been a while. Over the last 5 or 6 years, we've been working on Inner Orbit, which focuses around assessments for the NGSS. So I wrote a lot of the assessments on the site initially. Most of those are gone now because we have much better content on the site than I initially churned out. All this to say, it's a journey. And so we're going to start somewhere, and then we're going to get better over time. I now spend a lot of my time speaking with thought leaders. We are building out new products and new ways to support students and teachers. So some of that is going to be communicated to you today and shared with you, which I'm really excited about. And I'm also really excited to introduce my colleague, Julia.
Thank you, Brendan. So my name is Julia, and I was a teacher in the Dominican Republic and also a tutor later. And I've been building materials to support teachers and districts with their NGSS implementation for about 2.5, maybe almost 3 years now. So, and I'm Inner Orbit's district engagement manager. So if you're interested in trying this out with your students, if you want to pilot in the beginning of the year, please send me a quick email and we can connect later. But back to Brendan to get us started.
All right, and we're going to start at the beginning, and that is, why are we here to even talk about this? So Inner Orbit, we've been working on Inner Orbit for a few years. We've learned a lot of things, and we're crystallizing some of those little nuggets of learning into these webinars. And so what is Inner Orbit? So you understand what we do. So we find phenomena. Those are real world things that can be explained with science knowledge. And so we find events that happen in the natural world and give students opportunities to make sense of those things. So applying the stuff they learn in class to these new things. That application is very directed. And so we have all these questions that we build that are very specifically scaffolded. So we have some questions that focus on just the knowledge that students need, and some questions that focus on the cross-cutting concept, and then the SCP, and then we'll layer all 3 together. And all of that stuff is in service of providing useful, actionable data. So this right here is a report that you'll see after students go through and complete an assessment on the platform. So what we're looking at is the SCP developing using models, and we're looking at 2 different grade level bands of that SCP. So in 3.5, which is lower elementary or upper elementary, students need to do things like, build on their K2 experiences to develop and use models to describe and or predict phenomena. They need to use a model to test cause and effect relationships or interactions concerning the functioning of a natural design system. And because each of our questions are tagged with a really discrete part of these standards, we can report out and say students are doing really well on these 2 things. And at the middle school level, they're really struggling with developing a model to describe unobservable mechanisms. It's a very discrete piece of this science and engineering practice at the 6-8 level. So all of the state tests, they use all of these parts in the writing of their questions, but they don't report out at this level of detail. So what we want to do is give you an extraordinary level of detail so you can sit and plan for your district or your county, or you can sit and plan for your students in your classroom and say, here's where we struggled. This is what I'm going to try next. And then we'll reassess later on and we'll move the needle. And that's what we want to do. We also do a lot of professional learning. So part of that is happening right now. Hello, you're a part of it. Everything is focused around real research, modeling engaging classroom strategies. It's all driven by teacher feedback. All of the resources that you see today have been honed over years of different iterations. And so we're really excited to share them with you. That's my colleague, Erin. She's hanging out with some teachers in Connecticut there. We can come to you, or you can come to us virtually, and we can chat about the NGSS and about assessments. So we focus on both. But today, we're only here to talk about one thing specifically, and that is building initial NGSS capacity. Welcome to the starting line. On your mark. The objective for today is to explore strategies and resources for foundational sense making for teachers and administrators, any educators, and simple methods for gathering informal baseline NGSS data from students. So we are we're building a base here. This is the very, very beginning. And we're going to be here for about an hour talking about all of this stuff. And the first thing is, why start with why? And so we're going to talk about sense making. And we think of sense making very much as being the base for everything else that you build upon. We're going to talk about the golden circle. I'm not sure if you're familiar with Simon Sinek's work, but we'll be talking about that. And then we have a PD tool that we just developed, which is what is sense making, and it's a facilitator guide. We're going to kind of we're not going to go through this as students. We have many things we want to go through. We're not going to go through it completely, but we will share all of these resources with you after the event. So if you're watching this as a recording, look into the description of the video. And if you're here right now, we're going to send you an email after this with all of these resources in them so that you can review these things and use them and share them out with folks, because we just want to make things better. Then we have more PD tools that we're going to go through. First, there is our Science Talks template. This was built and created by our colleague, Erin Cook, who is amazing as a part of her PhD. And then we have the questions to dimension matching activity. This is going to go through the 3 dimensions. Everything before this doesn't really focus on the 3 dimensions, but this tool does. We can think of this as a stretch goal or extra credit, but we'll show you a little bit more about that. And then we're going to go over some informal assessment strategies. So at the very, very beginning, at the starting line, we don't recommend that you have formal assessments. We recommend that you find informal ways to get students to show what they know and make sense of phenomena. And that's really the big idea, is just getting started, making sense of phenomena at the beginning. We're going to go through some do nows and class noticings and wonderings. We'll talk about some common assessments, which this is something that is driven usually by a district leader or by a school leader, a department chair. And we'll share some stories from our friend Dan Covey at Oklahoma City Public Schools about that. And then data chess. Why does it have a question mark? And then finally, we'll have some closing and some Q&A. And we'll talk a little bit more about whatever you want to talk about. And so I'm excited to get started. Julia, you ready? All right. Start with why? Sense making. Okay, so Simon Sinek, if you're unfamiliar, so he has this book, and there's a really famous TED Talk. I think it's maybe one of the first viral TED Talks about starting with why. And so I want to frame this for us as professionals, as educators, and I also want to frame this for our students. Why should they do what we ask them to do? So what Simon says is, when we work hard for something we don't believe in, it's called stress. And when we work hard for something we love, it's called passion. So think about this through your own practice. Think about this through the new things that you're being asked to do. Think about this through the lens of your students. Like, they're sitting there in your classroom and you're asking them to do things. If we have motivation behind that and we're passionate about it, it's going to be fun. If it's something that we don't understand the why of, it's going to be stress, it's going to be work, it's not going to be fun. And so we want to give students this lens of understanding, why they're doing these things. So Simon goes through in his book, The Golden Circle. And so this is a framework for thinking about motivations, about where you should start when you're structuring something new. And so sense making is going to be the thing that we're talking about today. So there are different levels of this circle, and we're going to start with the outside. So when we talk about the what of something, it is what we're actually doing. So you can think about this as lessons or as curricula, the actual book that you're giving students, the actual slideshow that you're going through with them, the phenomena that you're giving them. That is the what. This is something that you need to have, but it's not where you need to start. It's something you need to have later, but we need to build the foundation before we get up to there. How are teaching methods? This is the finesse in the teaching. So you could have Open Syed, a high quality NGSS aligned curriculum, but if you don't know how to go through those lessons and how to inspire students to make sense of new phenomena, it's going to fall a little bit short of where that needs to go. But the true center and the true epicenter of all of this is the why. And so with science, this is pretty clear. So, we have students that we're building. There's a future being built for them that does not exist right now. And there are things that have happened in even the last 2 years that have revolutionized much of the world and changed a lot of what you see in your classrooms, I'm sure. Like, let's just pick on AI as one thing. And the world is going to change by the time these kiddos that are in our middle school or elementary school or high school classrooms get into the professional world. Something else is going to be there that's not there today. And so we need to have them able to solve problems and understand new things, take in new information and make sense of that stuff, and then leverage all of the knowledge that they have before. And that is the crux of all of this. So the golden circle is all about feelings versus facts. And so what that means is that motivation is driven by feelings, not the features or the facts of something. So we can't just give students cool phenomena and be like, get it? No, you have to motivate them. So this connects to sense making, because we want students to be making sense of new things and solving real problems. Open SciEd has this wonderful unit, which is just fantastic. It's a high school physics unit, and they talk about the power grid failures in Texas that led to loss of life and huge, dramatic, terrible consequences that occurred because of these things. These are real problems, and they want students to understand the electrical grid, the transfer of energy that occurs with electricity or the movement of electrons. And they provide this real thing. Like, we need to solve these problems. These are real problems. We need to solve them. You need to understand why these things happened. If we just start with memorizing facts, so this is what we used to be doing, students understand, students know, without a motivating drive, then the facts just show the what. And frankly, students aren't going to be motivated by just knowing things. That's not what we need. We want them to be solving problems. We want them to understand the why of all of this. So we do see a lot of our partners, and this is just kind of a final little warning in here, that they'll adopt a new curriculum and kind of like give it to teachers, or there'll be some new lessons that are rolled out. And if you don't understand why you're starting with something new, why we want to focus on sense making, it's going to fall flat. And the NGSFs, the reason for that is that the NGSS are such a paradigm shift in how science is taught and how students learn, that art of teaching and the why and the how, it's not in the lessons or curriculum. That is a what thing. That's something you get afterwards, where you're like, all right, I understand why, I understand how I'm going to do this. Now, what do I actually do? So if we move through the pages of a lesson, it takes students through the what. It's good. Students need to know things. There's nobody that's going to argue with that. But if they just go through the lessons, go through the pages of something, they're going to be at risk of completely missing the why. And what we find happening in some classrooms is that students' questions will be answered by the teacher. Instead of saying, I wonder, well, I guess we'll just have to figure that out later, which is frustrating for the kiddos, but it does put the burden on them to figure it all out. If we start in the why of what we do, science is a productive struggle. That's interesting. Does that contradict what we learned yesterday? Let's add that to our model. Let's erase that thing that we put in there yesterday and see how we can add to this and clarify it. This means that we're learning skills with content, and that's the SEPs and the cross-cutting concepts along with the DCIs. And we use those things to explain the why and the how of novel phenomena. As we said, so the world has changed a lot since the old standards were presented. The NGSS are new. They're all focused around just novel phenomena, real things. Students have knowledge. They explain new things. That is really what we need to build for our kiddos. And so that is why you need to start with why. And that's why we need to understand sense making. And so to give some concrete ways that we can understand sense making, we have some PD activities that we're excited to share with you. So this first PD resource is a newer resource, and Julie and I developed this pretty recently, and it's all about sense making for the NGSS. And we have a facilitator guide and some directions and slideshows and all that stuff that we'll send out after the webinar. So if you register for the webinar, you'll get an email with this. If you're watching the recording again, there's going to be a link to those things in the description. But I'm going to pass it over to Julia to walk us through some of the introductory slides to this sense making for the NGSS PD activity. Julia, over to you.
Well, thank you, Brendan. So this next slide that we're going to see, I want everyone to look at these two scenarios. So we're going to see one, I'm going to walk you through this phenomena. And this is kind of a modified question from an end of year test. And we'll consider the difference between these two questions. So again, this is a facilitator guide, and this is something that it has notes and everything that you would be able to use to facilitate this same activity. But the first question is, we want to ask, so which of these is a biotic part of an ecosystem? And then on the second question, centers, we are asking them, so based on the information, explain how resource availability affects populations in the pond between late August and late September. So now that we have these two different questions, I want to ask you, and these is the same thing, we're mirroring the same activity that you would be able to facilitate with this guide, but I want to ask you to answer in the chat. So what is the difference between these two questions, and why is it different importance for our instruction and our assessment practices?
And if you've been with us before, you've probably seen an activity like this. What this is one slice of this presentation that we're going to share with you after the session. And so we want to provide novel phenomena and ways for you to ask teachers to compare and contrast. So this is an older test question and an NGSS aligned test question. This is from the Colorado State test, the CMAS, but in everyone who is here, whether you're in New York or you're in California or anywhere in between those places, you're going to find phenomena-driven questions by this. So in the chat, think about this for a minute. I promise we'll stop talking and give you time to think. What is the difference between these two questions? And then why is that difference important for our instruction and assessment practices? I want you to think about the starting with why. Super interesting. So I see folks talking about recall and students talking about using information to explain what's happening. Julia, what do you see in the chat?
I also see open-ended versus just a multiple choice question. I also see that one is a straight up answer, just a fact. And the other one requires more thinking from the student.
I just want to give a shout out to the person who made the depth pun. That's some high quality commentary right there. And also I saw somebody asked what age group are these two questions for? So these are both middle school level questions. So biotic and abiotic parts of the system are from middle school standard, and looking at resource availability is also a middle school standard. So I think just one other note is that a lot of the responses will compare the multiple choice question to the question that is for response. So I want to say that though that is true, you could write multiple choice questions around the prompt given for number two, and you could give different answers. And those different answers would just include reasons why plant and fish populations are affected by resource availability, given the progression of this pond from late August to early September to late September, and then the underwater ecosystem in late August and late September. And so it is possible to write free response or multiple choice questions around that second prompt, but this question is absolutely multiple choice. Yeah. And by the way, if anyone, so I saw some questions asking if they can share recordings of this video. We want to share this knowledge with everyone who wants to hear it. So if you're going through our webinars, we will always post recordings to them on YouTube. And so if you're here right now, that's great. If you need to boogie for another reason, we're recording this and we'll be posting on YouTube probably tomorrow morning. And so if you ever want to rewatch this or share it with other folks later on, then please do so. And we'll edit out some of these long-winded discussions that we're having. But yeah, that's that. So thank you all very much. Yeah, and if this looks similar to New York's 5th grade test item, that's right, because all of these tests, so the CAST in California, the CMAS in Colorado, the NGSS test in Connecticut, the New York intermediate and elementary tests are all going to be really, really similar. So this is a middle school level question, but there are elementary standards that are very, very similar to this, focused on, ecosystem relationships and ecosystems, not resource availability. That's a middle school standard. Cool. Thanks, y'all. Anything else you want to call it, Julia?
No, but after this discussion with these two examples, I guess, and just as a recap, we are modeling what this activity looks like and how you can facilitate it to everyone. We'll share on the follow-up email, we'll share, and in the bottom of the description, we'll share the links to that same activity so you can replicate it and modify it to your context. But after these quick discussion with different examples, and after teachers have given their ideas, we walk teachers through the definition of sense making to help frame the rest of the activities. And the focus of this entire session is only understanding and applying the concept of sense making. Other activities in our webinar will dive deeper, but we really want to build a foundation in sense making with this activity before getting into the 3 dimensions and scaffolding strategies. So as we continue exploring on how to explain and better understand sense making, we consider also how we assess our students' understandings using Achieves criteria. So this slide has a full script for you to explain and dive into different criteria around sense making and assessment. And I won't necessarily go over all the points in this slide, but there are things assessments should look like, and things that assessment should look less like. So these are criteria that teachers can use to evaluate different phenomena and questions in the rest of the PD activity too.
And just to clarify, so Achieve is the group that worked with state partners to write the NGSS standards. And so we try to use as many primary sources from Achieve as we can in our actual PD activities, because those are high quality examples of exactly what we are supposed to be doing with that. And these are also the resources that states use to write their assessment items. And we know that because we speak to people who've written assessment items from many of the different states that we support that have NGSS related tests. So this criteria here, which teachers will then use on multiple slides after this, will be a good place to to kind of like bring together a bunch of these different ideas. And again, we're just focusing on building a base of sense making. Do you understand what sense making is? Can you identify attributes, so traits that are sense making and things that are not sense making?
Cool. And after we've gone through that criteria, we also want to emphasize the importance of ensuring that the phenomena that we present in assessment is really novel, or are really novel, actually. So when selecting phenomena for your classroom, it's essential to choose situations that are new and specific to your students. And we have 2 key considerations here. So the first one, if it's new to your students and not a scenario they have seen in class before, and if it's based around a specific instance and not a broad topic or a generally observed occurrence. So instead of saying evolution or biodiversity, focusing on very particular events or situations. So we included phenomena that we would use in different points of the instruction. And the first one is, how do we know if Darwin's finches are friends or family? And this is all about investigating relationships about these finches in the Galapagos Islands through their physical characteristics, behaviors, and genetic data. And then for our assessment phenomena, we would have, why is there such a selection of lemurs in Madagascar, which is just exploring the diversity of lemur species in Madagascar, various factors like geographical isolation, environmental conditions. So again, 2 different phenomena, one for instruction and the other one for assessment that should still be novel. And then Brendan's going to walk us through a couple of examples of the properties of elements, I think, next.
Yeah, and so this slide is important when we're talking with educators or administrators about phenomena, because what we found previously were folks using anchoring phenomena or like hooks and just saying like, well, I talked about a phenomena in this unit, and so I'm good. So what you should be doing is you should ask students to sort of like pick apart and better understand a phenomena like Darwin's finches, friends or family. And then later on, we can ask them about a different phenomena. And ideally, throughout the course of a unit, students should be exposed to many different phenomena, because we can see lots of things in the natural world that come to life in these standards or through these standards. And so that's the important piece here. We also want it to be clear that just because something looks novel or like looks like it's unfamiliar, it may be something that is familiar. And that is my lead into this next slide. So what we're going to go through here are several of the slides. So what we've done are for this PD activity, we have examples from high school. This is a high school chemistry example. We have biology examples. We have elementary examples. We have middle school examples. And so one of them that students or the teachers will analyze is this question about our friend boron. And so the question is, based on the periodic table, which of these elements probably has physical and chemical properties most similar to boron? And students should answer that question. We want teachers to go through this, and we have these check boxes that are already filled out here, but we would want teachers in this PD activity to go through this and have and say, are they representing something they've known before? Are they explaining something that they already understand? Are they providing a factually correct or incorrect answer? Or are they doing the things that we want them to be doing that look more like sense making on the right-hand side? And so this is an example teachers, either in groups or all together, or as individuals, could go through and answer these questions. You could print these slides out on papers and have teachers do it in groups or whatever it is, just have a group discussion. So the first question we'll offer is this. And then for those chemistry teachers, we could say, all right, now, predict another element that could be used in welding arcs. So I'm not sure if you know this, but argon is used as a shielding gas in welding arcs. And as you're, get your high powered, plasma that's melting metal, the reason the whole room doesn't explode is because this welding arc, this shielding gas, argon, has some special properties, which allows it to not immediately combust with the air. And so argon's really, really helpful in welding arcs. And we want to ask students what other things have similar properties and how could patterns of the periodic table be used to justify their response. This question is a better example of the things that we want students to be doing. They're connecting what they've learned about periodic table patterns in a new way. So maybe you just learned about argon and welding arcs right now. How fun is that? We want you to connect their learning to a phenomena that involves authentic uncertainty from the student perspective. And then finally, we want you to make your thinking visible. So they have to predict elements and explain how they would be used in welding arcs using those patterns of the periodic table. And this is all about valence electrons. That's what this standard is focused around. And so this is one way that we could allow chemistry teachers to examine two different questions and say, is this sense making or is this not? And again, we have a full script that's in the PD activity to go through all these things. And we compare these two different questions and ask and sort of like compare contrast each one of those things. In addition to the sea mass question we looked at earlier about the changing pond and the desert ecosystem thing. So we have other examples of these. I'm just going to kind of blast through them because we got a lots more stuff. So this is high school biology where we look at cellular respiration. There's a really simple question about that. And then we have a more in-depth question about starvation and fasting. And we ask teachers to go through and mark whether this meets the criteria on the left or the criteria on the right. Same for this molecular motion at the middle school level. So this is looking at how this question is like model how increased heat changes molecular motion. And then we'll ask another question, and teachers are comparing these two things. Use a model to show how heat and molecular motion explain the changes in the balloon. How come this balloon, when dipped in liquid nitrogen, gets all tiny, and then when we take it out of that and it warms back up to room temperature, it starts floating. So we want them to mark these things and say this meets the achieved criteria or this does not. We also have examples from elementary school as well. So this PD activity is meant to be done with lots of teachers, either teachers that are at the high school, if we're in like physics and chemistry, or if we're in a middle school, or if we're in elementary school. So this looks at weather patterns. And so we want students to look at ways that the weather varies over time, and they just need to look at weather conditions. And then we have another thing that focuses around, our friend Jun here, who's wanting to plan a beach vacation to Fort Myers, Florida. He thinks July is the best month to go. Do you agree or disagree? Use data from the graphs in your answer. So this is all about weather patterns. That's what the standard focuses around. And we just want to give teachers different ways to ask questions about this, looking at historical weather patterns and comparing two different data sets. That's what this is looking at. It's both temperature and rainfall, or tropic storms and rainfall. No, average temperature and rainfall. That's it. We have another one about tropic storms. Great. So that's our first PD activity that we're going to go through today. And what we want to do now is go through additional PD activities that you can do with your colleagues, with the administrators, with the teachers that you work with, to help kind of dig into the concept of sense making. It's been a journey in understanding the NGSS for us. And Julia's been working with us for 3 years and on this for 5 or 6 years. And frankly, there's a lot that we still are learning every single year about the NGSS. We also sit at a vantage point of getting to work with hundreds of different districts across the country and across the world. And we've seen implementations that go well and implementations that have struggled or stuttered. And always when there is a baseline understanding of sense making, everything goes better. So the second example activity is called a science talk. And again, this is just focused around understanding sense making and kind of like picking apart what students have to do in a given assessment task in order to make sense of it. So science talks is something that was developed by our colleague Erin Cook. She's amazing. As part of her work on her PhD, she worked with administrators on building PD tools for teachers to help better contextualize the NGSS. So lay that foundation for sense making so that they could do things like engage in high quality curriculum and instruction and engage in high quality assessment and data chats afterwards. So this is, again, just laying a second foundation. This is an independent activity from we looked at before. This is called the science talk. And so here's what the template is. Again, we will share these things out with you after the recording. If you're after the session, if you're watching the recording, just check the description, you know the deal. The summary of this is it's a resource for teachers to get some experience with a novel phenomena. This is actually an activity that can be done with students or they can be done with teachers. And so it's intended to give you a couple different ways that you can allow exploration of a new phenomena. So real low stakes. What we want to do are look at all three dimensions of the performance expectation. We're not going super in depth into like what an SCP is or what a cross-cutting concept is. So it's really just pattern matching between the text of that SCP or that cross-cutting concept and the text that we see in the prompts and in the phenomena. So we want teachers to understand, and students also, that they're transferring skills and ideas. And we also want teacher exploration of the SCPs and the cross-cutting concepts. As I said before, all of these initial activities are focused on sense making, just like transferring skills and ideas. Understanding the SCPs and the cross-cutting concepts is a different journey. And that's actually something we'll cover in our next webinar, is how you can scaffold that process up so that not just the administrators, not just like delivering this PD, but teachers are interacting directly with curriculum and assessment items. Assessment is what we focus on. So that's what we'll be talking about the most. Okay, cool. So we also have these talk moves to support discussion, not destruction, if needed. And these activities are intended to take 5 to 10 minutes. These are little chunks. And so in a PD session where you go over that sense-making guide, afterwards you can go through something like this, or before lunch and after lunch. And this is another way to just kind of like dive into a phenomena. So the template I'm going to go through really quick. And again, this has a full-fledged script that's associated with it. I'm not going to read all of these things, but at the top, what we want to do is have students, and those students can be groups of teachers in a professional development session, collaboratively explore novel phenomena through a structured discussion to encourage sense-making practices. So we're going to select a phenomena, and we're going to select some focus questions, and then they're going to go through and kind of look at each of these elements of this. So what's the phenomena that you're looking at, and what are the focus questions? We have some that we've identified, but we also have lots of these on InterOrbit. So more on that later on. So what teachers will look at is teachers or students, is they'll look at the dimensions of the standard that are focused in that. And we'll also say that we want students to take those things and not just the knowledge they have and use that for independent sense making. So if we have conversations that are structured, it's going to help with independent sense making. And it's also going to form well-rounded scientists. It's great to have a passion for biology or chemistry or earth science, but understanding all of these things and how things like the SCPs or the cross-cutting concepts come to life in all those standards is really important. And that's what we really want to do, is we want to apply the ideas from each of those domains across a variety of different phenomena. So in the Science Talk template, there are a couple things that we want students to do, our teachers as students as well. So they're going to read aloud the phenomena that they're given, and they're going to say, what do you notice happening here? Or what experience have you had with this? So what research says about this is that students' ideas, so conveying their prior knowledge, experiences, members of family, communities, interests, and curiosities can be leveraged to move the whole class learning forward. And also students that are aware of their ideas and that those ideas are valued. And that is very important. So what we're trying to do is build a base for comfort and understanding for community and bringing in things that students and or teachers already understand about the topics that we're talking about. These are all best practices. So this is what we want to start with. And then later on, we'll dig into the actual questions. What is this question asking us to do? How is it connected to the science and nature of practice or the cross-cutting concept? And we want teachers or students to dive into and say, oh yeah, this is how I construct explanations, or this is how I focus on that cross-cutting concept. And what research says about this is that if we consider learning to be not just a personal act, but also a collective endeavor in which students reason together, then talk is important because it transforms an individual's ideas, puzzlements, conjectures, and questions into public resources for others to think with. If you've not read Ambitious Science Teaching, we would like to put a plug in for that. It was a company book club book some time ago, and it's an excellent read. It's probably going to reinforce a lot of things that you know and love already about the science classroom. It's going to give you other structures, concrete structures and ideas to to move forward with. So that's what we're looking to do. So this PD activity is intended for adults and or for students. And so a question that I have for y'all in the Zoom right now is, let's just say you were giving this to students. When during a unit would you want students to go through and have a science talk? So a discourse about novel phenomena. Let's take a minute, respond in the chat. Let us know when during a unit you might have students sort of like pick into a novel phenomena. All right, so I'm seeing beginning of the unit. I see a couple of people that said all the time, or at the beginning, in the middle, the end. Somebody else said to engage students before an assessment, which I think is a super smart idea. This is like a piece of scaffolding that we have talked about in prior webinars, which is that going into the phenomena before students take an assessment on the phenomena is a good way to scaffold up and sort of pick out relevant details and skills, or like decode models and stuff like that, or data sets for students to make it a little bit easier. I like the idea of starting with it and then revisiting it later. That's really, really interesting as well. And maybe if students are struggling with the concept, that might be a good way to say like, okay, it looks like we're struggling with this. Let's pull everything together. Oh, I love this. Cool. Yeah, I think as an introduction and a summation, engaging in the beginning is obviously fantastic. So if you look at high quality curriculum for the NGSS, things like OpenSciEd, the anchor phenomena is revisited throughout. And then there will be sprinkling in other little phenomena. Whether you need to go through an entire like discussion around each of those phenomena is up to you. And this is just a tool you can leverage. But this is a structured tool for looking at very, very specific pieces of a phenomena and those questions and seeing how they align to the standard and to students' prior knowledge and experiences. Great. Thank you so much for all of your answers. It is fantastic to see what y'all are thinking. So in summary, what these are again, allowing students to collaboratively explore novel phenomena through a structured discussion. And we want to encourage sense-making practices. So we just want to stir things up so that when they go into a formal assessment later on, they could go through this. And they would have this process kind of like in their back pocket, and it would be familiar to them. This is fast. This is a 10-minute thing. We do this in our PD sessions with teachers all the time. And it's something that we do real quick. And we'll, narrate and give some background as well. But a lot of it is just allowing groups of teachers to go through and do this. And then we say, wouldn't this be fun for your students? And they say, yes. So this is just scaffolding towards independent sense making. It's not focused around SEPs. It's not focused on the cross-cutting concepts. You're just applying, and mostly pattern matching between the text of the questions, the text of the standards, and making sure that those are things you can engage with. So how can NORB help with this? So we have over 1,000 phenomena, and we have over 10,000 questions. We're writing more every single week. So if you're on the site today, you're going to see more questions on the site a week from today, because that's kind of what we do. InterOrbit is intended to be more than just pen and paper or screen and keyboard. So assessment can be informal, assessment can be a conversation, assessment can be collaborative. That's super important. We are also looking to provide rich examples of phenomenon content and sense-making questions for educators. A lot of folks that are training teachers will use our assessments as a way to see, that's how a cross-cutting concept, an SEP, or all three, can work in concert in an assessment item. Then that helps with saying, all right, now what would those look like in my classroom, and how can we incorporate that questioning with our students? So all of this is just meant to drum up, additional ideas for teachers, because when you see something in practice, it's easy to imagine other ways that you can scaffold up to it. I think we as educators are very good at finding ways to scaffold up to things, as long as we know what the North Star is. We have a goal, we have an objective. And finally, all of our later questions on InterOrbit are focused on mastery of a performance. We call those sense-making questions. And so what does it really look like? What does it sound like? And what are the phenomena that can be used to build mastery-based questions look like too? Awesome. Thank you all for going through that with me. We have one final activity to show you, which is called our question to dimension matching activity. This is something that was also designed by our colleague, Aaron. And so this is intended to kind of give either students or teachers, allowing them to see what the assessment of the 3 dimensions looks like. So in our intro slide, we call this stretch goal, kind of like this is like extra credit. So it's great. Understanding sense making is the most important part. And after that, then we want to start to talk about what integrating the 3 dimensions, the SCPs, the cross-cutting concepts, the DCIs look like. And so this is after the base of sense making has been laid. then we can start to talk about those three dimensions. InnoOrbit has some strategies for scaffolding questions of using just one dimension in isolation, two dimensions, or all three dimensions. So some questions focus on knowledge, some are knowledge and cross-cutting concepts, or knowledge and the SCPs, and then others are three-dimensional questions. This somewhat mimics what most state tests are also doing, where they'll have some lower level questions and higher level questions. Most of that is just leveraging how much sense making or how much students have to make sense of something and call upon their skills and those cross-cutting concepts. So what we do in our questioning and in this question dimension activity is focusing on those two-dimensional questions when it comes to scaffolding. So this is an activity that we have, and I'm just going to give you a little sample of this real quick so you can see what it looks like. But here's a copy of this. And so this is for high school chemistry. We actually have examples of this for chemistry, for biology. And in this slide right here, you can see pretty clearly that, let me go back one more, that we have this for third grade, fourth grade, fifth grade, all middle school content areas and all high school content areas. So you can dive into this pretty easily and see, what does sense making look like? What does leveraging those three dimensions look like? So this is another highly scaffolded and very scripted PD activity. So you can see, what this is, what it's for. We have some goals, we have some requirements that we need you to know before you get into this. And then there's a full-blown activity. Aaron has a video that introduces the activity, and then there's a series of questions. And so this is one of the actual slideshows, or a copy of them. And so we'll have a link to this in the description below this video, and we'll also send these things out in our follow-up emails after the webinar. So if you're interested in diving into this, please do, and we would love to hear your feedback on that. And now let me go back into our slideshow. So this PD activity is intended just to give ways for teachers to examine what one-dimensional, two-dimensional, and three-dimensional questions look like. So each of these things are, we're not going to dive into each of these on the own, but what teachers are going to do is they're going to explore phenomena, and they're going to try to figure out, is this question hitting the cross-cutting concept, hitting the SCP, hitting two of those together, or all three at once? And so each of these are ways for us to see that's what a cross-cutting concept looks like. You could easily have teachers go in their content areas. So if I'm a bio teacher, I could go into the high school biology, or you could ask teachers to go from bio into chemistry, or from earth science into physics, or from chemistry into middle school life science, and allow them to see, cross-curricular connections using those SCPs, those DCIs, and those cross-cutting concepts. Again, this is more or less of an extra credit activity for you to go through with your students and teachers, but we just want this to be a way for teachers to be able to come together and look at the three dimensions all together and say, I understand now what an SCP looks like, what a cross-cutting concept, what a DCI looks like in an assessment item. All right, great. And now what I'm going to do is we are going to go through some informal assessment strategies. And so these are ways for us to sort of informally assess students. So everything we've been focusing on so far are things for teachers. Maybe you could give them to your students as well. Like the science talks is meant for both, but these are intended as informal assessment strategies. So where do you get started with students? So in the very, very beginning, the informal strategies should focus on do nows. So this is an example of sort of one of the experimental materials that we've been building for the NGSS. And we have this young gentleman who's struggling a little bit. And if you've ever been in their shoes before, this is a painful thing. So we ask students, which body systems might be interacting with each other to cause brain freeze, and why do you think this? So this is intended to be, it could be an introduction to a unit. It could be in the middle of a unit. You've been going over some other body system interactions, and now we're going to talk about brain freeze for a quick little do now. But these are intended to be do nows. We also have a word bank that can be used with this. So there's some speaker notes. I'm going to drag that over here real quick. So we do give students sentence starters and word banks for these questions if it's something that's helpful. So these are some resources that you can use to give students really informal ways to look at a phenomena and make sense of those phenomena. In the sort of like teacher-facing slide that we have for this, what we also want to do are explain how this phenomena uses a performance expectation and how it uses the DCIs, how it uses the cross-cutting concepts. This is a do now, and so it's not intended to be something that you would give as a formal assessment. And also because it's a do now, we're also not using the SEP in a meaningful way. Science and engineering practices are deep, deep things that take a long time for students to truly, like explain their thinking of and, show how or why something's happening. So we just want to use this as a way to make connections between the systems that are connected and the fact that bodies are made of systems. Those systems have different levels of organization that all work together. Cool. And then finally, we also have some stretch goals afterwards. So if students were able to answer that first do now question, maybe we can go further to say, how does brain freeze demonstrate that cells and tissues in the body work together as systems to perform functions? Or why might some seemingly annoying body functions actually be very important? And if you can provide an example of another body function that is annoying but important, all of these are just intended as do nows for us to give students at some point during instruction. It could be before instruction, it could be after a phenomena we've been looking into for a while, but we want to allow them to informally make sense of phenomena, noticings and wonderings, class discussion, real light. We're just going to boop those things on the nose and they're going to move on. And this is one of the ways that we recommend introducing assessment into your classroom to get started. We also have differentiated review. And so oftentimes what we'll do is we'll find teachers looking at one performance expectation with one phenomena. And if you go into inner orbit, you can search for a standard and you can bring the heat slowly with kiddos. We can ask questions. We can build mild assessments using just our prior knowledge or on grade level knowledge questions. You can also use our on grade level and two-dimensional questions to, build a medium assessment, or you can get real spicy, like Shaq's experiencing here, with some two-dimensional and three-dimensional questions. So this is another way you can kind of build simple questions for students where either you're printing these things out, you're projecting them up on the board, and you're giving students ways to slowly introduce themselves into more complex questioning, like what they're going to see on the end of year exams. More on these questions in our next webinar. In this webinar, we're just focusing on ways that we can give informal assessments, just real light and easy. We want students to feel comfortable discussing phenomena and hearing each other's ideas and being resources to each other. And so now let's go into one of the first steps that we see our most successful districts taking in their journey. And that is one district-wide common assessment. So if there's one thing, and we talk to our colleagues that work with our schools and districts, if there's one thing that we see people being the most successful with, it is a single common assessment. And we have a partner who we're going to showcase, and they are going to talk a little bit more about their experiences with common assessment. And we have an entire webinar on this. We won't go too far into it, but I'm going to go ahead and pass this over to Julia to start walking through some common assessment strategies and how our partner in Oklahoma City is using those strategies.
Cool. So let's dive into this very, very quick case study. So for some context, Oklahoma City Public Schools is the largest school district in Oklahoma, and they needed to be able to predict student outcomes for a standardized test. However, their strategy and assessment system in place did not provide enough data and tools to do this. So the questions in these assessments were very content specific, focusing only on DCIs, and the questions were not necessarily aligned with those performance expectations and the standards. So with this being the only instance where students were assessed, the teachers did not have resources to provide students with opportunities to transfer that knowledge into real life scenarios. So they had to do something. And we interviewed the secondary science curriculum coordinator, Dan Covey, on the outlook of this story and what were the contingencies put in place. We have a whole webinar, as Brendan mentioned before, on this, and I'm going to drop the YouTube link in the chat. Oh, thank you, Brendan, for doing that. So I recommend watching this, and I'm going to highlight some main points discussed in the webinar to give context for building your own district-wide common assessments. So Dan shared some specific steps to achieve successful backwards design and planning. And first, we have to determine what is the end goal. And for this, we need to ask and define what are those standards that we need students to be able to master by the time they leave school, or as Dan calls them in some instances, the end game. And then we move on to standard bundling, where they figure out a structure where standards are bundled together to narrow down the steps to achieve this end game. After that, we're going to identify what are those priority standards to focus on in PLCs by understanding a little bit more in depth the progression of these standards and determining what are the next steps. And finally, we're going to start creating our own assessments. So developing different versions of common formative assessments with different phenomena and questions is crucial also to give students multiple opportunities to transfer their knowledge to different scenarios as they would have to do it on a standardized test. So Brendan's going to cover a little bit more about how these assessments are created and designed. So over to you, Brendan, again.
Thank you, Julia. And so Oklahoma City does this they have a bunch of these common assessments that are built out. I think it's over 200 across all of the different grade levels and subject areas. It's bananas. It's incredible. Their teachers do a lot of reflection. But all of our partners, the one common thread and the greatest success that we see in implementation is a single district-wide common assessment as a starting point. So usually the district coordinator or the assessment coordinator or a department chair will build a single assessment. And those assessments have the following attributes. So oftentimes there'll be 5 questions total. So really simple. This is not a big, hairy, like we're going to do an endurance test and run a marathon. No, you're going to go out, you're going to put your shoes on and you're going to run a mile. And that's it, like real quick, maybe not even a mile, maybe just like a quarter mile or something down the block and back. Version A of these assessments, so what Dan used for these and what we recommend as well, is using our content-only questions, some two-dimensional content and cross-cutting concepts, two-dimensional content and SEP, and then a sense-making question. So these are really short assessments. What Dan did is he built one for using the phenomena, how do sweat glands help us thermoregulate? And then a version B, which is why do we shiver when we're cold? And what teachers do is they give version A when they think that students are ready, and then inevitably, there are some areas where students struggled. They have some instruction that they do to respond to the results of the assessment, and they give version B to see if they were able to move the needle between version A and version B. So super helpful way for you to just get started. And so we have the webinar linked up in the description of this video. And so if you want to check out that whole webinar where Dan talks about his common formative assessment strategy, that's great. But if you're just getting started, do one common assessment across your grade level, across your content area. That's the place to start. And then from there, in year 2, try more of those. Have more data chats. So real quick, after we've talked about ways to lay the foundation for sense making, ways to guide students towards, or teachers towards some initial implementation of either informal, or you could do a more formal common assessment, let's talk about data. And actually, you may be ready to talk about data. You're like, we're used to PLC meetings and all that good stuff, but not yet. So data chats are something that we don't recommend leaning into at the very beginning of your implementation. Instead, what we recommend is that you as a district coordinator, as department chair, or as somebody who leads, a group of districts, that you use the initial results and you process those things within a leadership team initially, and then you report out on sort of real high level details of those things. You can have teachers look into the assessment, look into the reports afterwards, and then later on, in other levels of implementation, and we're going to get to the building strength and building distance in our next session. So those will focus around having common assessments, usually having teams of teachers build those assessments, having teams sit together as PLCs and look at data together. But all of that is predicated upon understanding sense making at the 3 dimensions, which are all the things that we did earlier. And if students don't have any informal experiences with looking at new phenomena, none of that is going to be accessible. So that is why we are building up to that point. And now we're at the end of our webinar. And Julie just dropped the link for our next webinar into the chat. If you haven't already signed up for it, we would love to see you there. This was intended to be a starting point. Literally, the starting line is the name of the webinar, where we talk about some basic strategies for getting started. But that next webinar is going to focus on building distance, building strength. And so not just going through the basics of what the NGSS and sense making look like, but how do we take it to the next level? How do we get students ready for that state test? And that's kind of the next session that we're going to focus on. And we're really excited to have you there. So now that we've gone through all of this, if you do want to find a time to chat with us, we'll drop a link to our calendar in the chat. We would absolutely love to meet up with you and show you around. You'd be talking to Julia. She's amazing. And you can also sign up to explore a pilot on your own. Yep, and there's the link to our next webinar, which is Strengthening NGSS Proficiency for State Tests. So go ahead and click on that link and sign up for that webinar. But otherwise, we'll hang out for a couple of minutes and answer questions. But we're really grateful that y'all were here. You spent the time to build your practice and to reflect. It was wonderful to get to chat with y'all. Take care, and we'll see you later.